Welcome, everybody. This is the first in our series of webinars on how to achieve single sign-on across multiple clouds. My name is Rodney Buki. I'm a solution architect at CMS, and we'll get started with some housekeeping. Just to let you know, we will be taking questions throughout the session. You'll see a Q&A pane pop up at the bottom, and you can switch over to that and enter your question, and we'll answer those as they come about. This session is being recorded, so we will have it available for download afterwards, both the recording and the PowerPoint, and you'll be notified via an email once this webinar series is over. Just as a quick note, who we are, CMS Consulting is an award-winning boutique firm of senior trusted advisors who design, deploy, and operate Microsoft infrastructure technologies. We've got approximately 50 full-time staff working to deliver projects in the Microsoft infrastructure space. This covers our practice areas from collaboration, including Exchange, Link, Enterprise Voice, Office 365, through to the data center, desktop, and cloud, both public, private, and hybrid cloud scenarios. So what is single sign-on? Single sign-on is really a process that allows a user to authenticate once and gain access to multiple different services. Once that user is authenticated to those services via single sign-on, they no longer are prompted to provide credentials as they switch between applications and services. So as an organization who you may use both on-premises and cloud-based services, this allows the user to have a single password that they log into in their enterprise environment and then gain access to those various cloud resources and cloud services without being prompted for multiple usernames and passwords. This is leveraging an industry standard protocol called the Secure Authentication Markup Language, also known as SAML, which is at version 2 now. And any enterprise-worthy cloud service is relying on this to provide authentication services. So a question we often hear is, why does single sign-on matter? There's really kind of a few key areas where SSO matters in an organization. First of all, it really allows for one credential for all enterprise services, both on-prem and cloud-based. This reduces the sort of password fatigue that a number of users have. It also improves security by allowing users to have that single password and single username for all services. We all know that users are sort of famous for simplified passwords and writing passwords down. This makes it a lot easier and improves the user experience for those end users who are accessing these services. It also reduces administration and improves security by leveraging Active Directory security and controls. So when we look at a cloud-based service that you may use for purchasing or for HR purposes or sales purposes, we can create groups within Active Directory and then use those groups in Active Directory to give users permissions to cloud services in the same manner as you would giving them access to an internal SharePoint site or internal file services. This makes administration easier because no longer does an administrator need to manage both on-prem services and the various cloud services, but it also improves security by being able to leverage those security and controls with Active Directory, things like password resets and password policies. Now, there is some confusion. We hear often around single sign-on versus same sign-on, also known as synced sign-on. Single sign-on is leveraging the Secure Authentication Markup Language and authenticates automatically via the directory service. Same sign-on synchronizes your directory service, but requires the user to provide credentials when accessing those applications and services. So with same sign-on, we're synchronizing both the user ID and user credentials with the cloud service, which requires then that user to sign in using their Active Directory controls, having to provide that username and password, as opposed to single sign-on, which means once we're logged into our corporate systems, we have access to those systems automatically. Now, in the Microsoft space, ADFS, or Active Directory Federation Services, is the role that provides this authentication within the Microsoft infrastructure world. ADFS follows the industry standard SAML version 2. Microsoft hasn't made any changes to this. They've implemented SAML v2, and it's known as ADFS. And ADFS is supported by all major enterprise cloud services. Office 365, Salesforce, Workday, and so forth all support Active Directory Federation services, as does Google Apps. ADFS is included in the operating system. It's a role. It can be installed on the domain controllers themselves. It doesn't require any additional licensing in your organization. So the architecture for ADFS is fairly straightforward. There are a few servers that are required. There's the ADFS server, or Active Directory Federation Services server. This can be your domain controller. It's simply a role that's installed on a 2008 or newer server that enables the authentication services to take place. The second server is an ADFS proxy server. This is optional in certain cases. Some edge devices, firewalls, TMG, UAG as an example, provide proxy services for ADFS. However, if you do not have one of those systems in place, we can deploy an ADFS proxy server, which is a non-domain joined machine that sits in your DMZ with public-facing IP address, and this device proxies those authentication requests from the cloud service through to your ADFS server, which then authenticates the user via your internal Active Directory. Now you can see we've got two ADFS proxy servers and two ADFS servers. This provides basic high availability. So if one of the proxy servers is unavailable or one of the ADFS servers is unavailable, authentication requests can still take place. An additional high availability option is to place ADFS both on premises and within the cloud in Azure or Amazon EC2 as an example. And this allows you then to have high availability for your ADFS infrastructure between on-prem and cloud-based services. So how does ADFS work? So in this case here, we've got a user who's going to access a cloud-based application, and we've got our internal Active Directory services. The user will browse to the application, and that application will then send a request for authentication. Once we discover the user's Active Directory information, we can redirect the application to that system, which will then create an authentication ticket request. The ticket will come back, be sent to the application, and the user will be provided with the access to the application. It's a fairly straightforward process. As far as the user is concerned, all this happens behind the scenes and nobody has any notification as to what's going on. One thing to note with this is when we get into this type of scenario, there's a lot of different moving parts in this type of infrastructure, and so monitoring both ADFS and the on-prem services, as well as network connectivity, proxy servers, becomes crucial to ensure that this works. From a user experience perspective, there are various different types of user experiences based on the implementation of ADFS that you've put in place. There are three basic infrastructures that we can put in place for ADFS. One is using ADFS and Windows integrated authentication. Another is using ADFS and forms-based authentication. And the last is using ADFS and an ADFS proxy server. The user experience will vary depending on which service you have in place and whether the user is internal or external, and whether a domain user or not a domain user. Typically, the infrastructure that we put in place would be the ADFS server with the ADFS proxy. This provides the best of both worlds when we look at how to implement ADFS in an organization. As an internal domain user, it's true single sign-on. So the user will log into their corporate machine, and whenever they try to access an internal or a cloud-based service, they'll have the ability to access those services without any additional password prompts. For an internal user who is not joined to Active Directory, they will get requested for a pop-up dialog, but most applications will allow you to save those credentials. Outlook and Link as an example, when running on, let's say, a Mac device, will get popped up for credentials for accessing Office 365 via Outlook as an example. You can simply save those credentials and they won't get asked for those credentials until they change their password. Form-based authentication will be a website similar to what you might have seen when you logged into this web service or was the Link web application, and we asked for some basic credential information to log into the application. When using ADFS with forms-based authentication, that will be the authentication method across the board. And with Windows integrated authentication, if you're an internal or external domain user, you will have true single sign-on versus a non-domain user who will get requests for credentials each time they launch the application. Now, ADFS in the real world is typically, from our experience, we've deployed a lot of this with Office 365. Office 365 is one of the cloud services that does support Active Directory and ADFS for Exchange, Link, SharePoint services. And basically what we do and how this works is your internal Active Directory is synchronized with the Azure Active Directory, which backends Office 365 via what's called a DIRSync server. So in the bottom right-hand corner, you'll see your Exchange hybrid server, and you'll see above that a DIRSync server. And the DIRSync server does the directory synchronization between your on-prem Active Directory and Azure Active Directory. Once that's synchronized, then Office 365 has the ability to link Exchange email or Exchange inboxes, Link user accounts, SharePoint user accounts with the Active Directory credentials as you specify them within your domain. This then allows the authentication request to be proxied back through your ADFS proxy server and allows you to use your internal Active Directory credentials, usernames, and passwords to provide that single sign-on scenario. As I mentioned earlier, there is another option called same sign-on or synced sign-on, and in this case, the DIRSync server would synchronize both the user ID and their credentials into the Azure Active Directory. That there, however, would require the user to provide their name and password when they are accessing the cloud-based service. Now, there are some deployment considerations as far as planning, high availability, and disaster recovery. From a deployment planning perspective, performance is key, as well as operational security. Performance, obviously, if we don't have the performance, this can implement or increase latency, increase challenges, and the performance of the applications themselves. If ADFS and Active Directory is performing poorly, that will have an impact then on how quickly users can log in to those various cloud resources in the same manner as it can impact the performance and accessibility of internal resources. Implementation and security, from a planning perspective, is the same as any sort of internal application. If we are deploying an internal application, we're creating specific user groups and accessibility permissions so that a user can access that internal application. It's very similar to doing that with an external application. So from an HR perspective, as an example, if we're adding users to the HR group, we need to be able to map that to the group within the cloud-based service so that those users then have simplified access. And we just need to add that user to the Active Directory group in order to give them access to that cloud-based application. The biggest deployment consideration, though, is high availability. With Active Directory federated services, if the ADFS proxy or ADFS servers are unavailable, that prevents users then from having access to those cloud-based services because the authentication requests will not be authenticated. So high availability becomes crucial. So multiple ADFS proxies and multiple ADFS servers on-prem is one option. However, that doesn't prevent you from losing access via data center outages. Typically, if there was a data center outage with a cloud-based service and you had high availability for your ADFS, the user could go home, they could go to a coffee shop, a Starbucks, whatever it is, and gain access to those resources. However, if ADFS becomes unavailable, those users would have no ability to access those cloud-based services. This is where high availability leveraging cloud resources comes into play, and placing ADFS servers both on-prem in your data center and either in another data center, a DR data center that you may have, or in a cloud-based solution like Windows Azure or Amazon EC2. This provides both disaster recovery and business continuity services by being able to provide ADFS infrastructure services to authenticate users to those applications and those services based in the cloud. So a typical Active Directory Federation service engagement is roughly 10 days. There are a number of servers that get built. The DirSync server for synchronizing directories is the first server. This is just a single standalone service. There's no need for high availability on this system. If there's an outage with your DirSync server, it typically won't impact any day-to-day activities. The ADFS server is used for authentication requests, and typically we'll deploy 2 of those on-prem, or 1 on-prem and 1 in a cloud-based service, such as Azure or EC2, or in a DR data center. Same with the ADFS proxy. Those are used to proxy as the authentication requests coming in from the internet to your ADFS server. And we'll typically deploy 2 of those, 1 on-prem and 1 in the cloud, or 1 in a remote data center. The next step then is to integrate with the various cloud services that you have deployed. As I mentioned earlier, ADFS is supported with Office 365, Google Apps, Salesforce, Workday, ServiceNow, and a number of other enterprise-ready cloud services. The final steps are to document the build and the configuration so that you've got the information on how to back up and restore your ADFS and DirSync infrastructure if something goes wrong, how the system was configured, how it needs to be reconfigured, and how to provide backup and disaster recovery services for the infrastructure that was built. The last step then is knowledge transfer, and that's training your staff so that they understand how the system works, how to manage the system and monitor it for best performance, as well as how to integrate with other cloud services or make changes to cloud service configuration if needed. Now, to summarize, Active Directory Federation Services is Microsoft's implementation of the SAML v2 industry standard. This is used across the board by enterprise-ready cloud services. I've listed off a number of them before already as to what they are. And as new cloud services come on board, SAML is the industry standard and is the one that will be used to provide single sign-on. Single sign-on is critical to secure and provide easy to access, easy to manage cloud services. By being able to leverage your Active Directory security controls, it makes it easy to manage, and no real retraining is required for your IT staff because they're simply adding and removing users to groups, providing password policies and lockout policies as you would with any Active Directory based service. And then from a end user perspective, we really have the ability then to provide an easy to use system, easy to access, a single user, a single credential, a single password to the various different cloud services that you're providing. The biggest consideration with any ADFS infrastructure is the high availability and disaster recovery requirements. This really needs to be considered to provide 24/7 access to those services because if ADFS goes down, that then prevents users from logging into those cloud-based services. So HA and DR really become crucial to a functioning cloud service infrastructure. We have a few references. Our CMS blog has a number of different blog posts on experience from the field deploying ADFS, as well as integrating ADFS into cloud services such as Office 365. Microsoft has a little bit more of an in-depth overview of ADFS at at the URL specified there. That will take you to the TechNet page covering ADFS in depth. There's also a in-depth look at ADFS and Office 365 and what the requirements are there as far as directory synchronization, Active Directory Federation services, and the various scenarios with Exchange, Lync, and SharePoint Online. And finally, Channel 9, Microsoft's video series, has a deep dive on setting up and configuring Active Directory Federation services in your environment. The video is about an hour long, but it goes really in depth as to the requirements for Active Directory Federation services and how to get that running within your environment. Before we open up the Q&A session, I just wanted to let you know about 2 more webinars that we have coming up. The next one coming up in the April timeframe is what's the difference between private, public, and hybrid cloud scenarios. There's a lot of confusion between what those systems are, and we'll sort of split those up and discuss what the options are there and how they work together. And the last is how to transition to Office 365. Those ones will take place in May, and that's how to take your Exchange, Lync, and SharePoint infrastructure that you've got in place today and make it migrate those systems to Office 365. If you go to cms.ca/learncms, you'll find more information on how to access those webinars. So the Q&A panel is now open. You can switch to that panel and ask any specific questions that you may have, and we'll answer those. If you have any additional information or questions after this webinar, you can contact us. Our information is up there on the screen. It's very easy to remember. Email info@cms.ca. With that, we'll take any questions that may appear. All right, if there's no questions, I'd like to thank you for joining us in this webinar. We do have one question that just came in. The question is there a public list of cloud services that ADFS supports? Not that I know of. I do know that any of the enterprise type systems that we've worked with do support ADFS. Most of the cloud services won't necessarily say that they support ADFS specifically, more that they support SAML v2. Microsoft's implementation of SAML v2 is ADFS, so if you see something out there that supports SAML v2, it supports Active Directory Federation services. So we'll stay on the line for a little bit longer in case anybody has any more questions. If not, I'd like to thank you for joining you and hope you join us at our next webinar. Thank you. I'm on mute now, so I